What's up, data friends? It's Yanis here and welcome to my channel. Now please note that this video is actually video part 2 of the supervised machine learning models example. This is a classification example. And more specifically, in this series of videos, we are solving this spaceship Titanic predictions Kaggle competition, which we are basically trying to predict which passengers are transported to an alternative dimension, yes or no. So as I said, it's a classification model example. Now, as I said in the previous video, I expect you not to be a beginner to follow this tutorial. So if you are a beginner, I suggest watching my first video, which is a Python tutorial for beginners in data science, where we explain NumPy, pandas, joins, visualizations, and basic machine learning model example, which is another video before following this video. And just to do a quick recap of the previous video, so we've touched on what is machine learning and how it works, what is the machine learning process, then we loaded and investigated our data, we've done some data cleaning, some data visualizations, then we investigated the missing values, we investigated our distributions, we've scaled and transformed our data, we've selected the most important features by running correlation coefficients and feature importances, then we've trained and run one model, so we didn't optimize this model, and then at the end we've run all the steps we did before on our test data, then we made predictions on our test data, we submitted our predictions into this Kaggle competition over here, submit predictions. We got a result of 78% accuracy and a place of 1000 plus. So in this video now, we are going to try to improve our results as much as possible. So we are going to try model optimization. We are going to try a new way of replacing the missing values. We are going to try and run models with the most important features only. We are going to try the recursive feature elimination algorithm. And then at the end, we are going to select the best performing model, run predictions, output our data into a single CSV file, and then we are going to build this Power BI dashboard, which I don't have open, I think is this one, from scratch. So we're going to have our actuals and our predictions, and we are going to show an example of how we will go about deploying our results with the business by building this dashboard that you're going to see right now that has all of the actual data and also our predictions. So the business can now see what's going to happen on the new data, who is going to get transported, yes or no. They get the details over here. Right, and if we go back into our notebook now, as always, I'm going to have this notebook with the code and the raw data and the Power BI file uploaded in my GitHub page. So you can follow the link in the video description and you can download all of these files. And before we start this tutorial, let me just say that if you're passionate about data analytics and data science, then I would really appreciate it if you click the like button, subscribe to my channel, and enable notifications for my future videos. Right, starting from where we left it in the previous video, which is up until here, the model optimization. So we've just run our model and we got 78% in the unseen data in Kaggle. However, over here, our model got 80% and a 0.40 log loss. If we try to improve this model just by optimizing it, so without changing anything else, we'll need to follow the below steps. So it's the same classifier that we are initializing. It's an XGBoost classifier. First, we need to define all these parameters that we are going to loop through in order to find the optimal parameters. So we are going to try a lot of different combinations of learning rates, different combinations of max depth, mean child weight, the gamma, then the call sample by tree numbers, and also different subsamples. Then I need to initialize this stratified K-fold. So this is the cross-validation technique that we are going to use within the randomized search CV. So you can see it's over here, cross validation. We are going to do a 5 split cross validation. And after this code that we've just initialized the stratified k-fold, we need to initialize and also feed. Actually, the feed is down here. So we're just initializing our model. So if we check the parameters quickly, we are going to call this randomized search CV, which basically what it does is that you first need to pass a classifier. So we've initialized this classifier, but you can pass any classifiers here. Then you give it the parameters that you want to loop through and find the optimal parameters. So instead of doing a grid search on your own and looping through all these different parameters, you can actually use this library called randomized search CV, which does this for you. So you don't have to write for parameter in and then pass the list and then loop through. Right. So in this model now, in this search CV, we pass our classifier, we pass our parameters, which are these parameters over here, the number of iterations. Our scoring is going to be the ROC curve. I have also tried accuracy here and also log loss, but I got pretty much the same results. I'm going to show you later on actually where I've tried different scoring methods. Then our cross validation is going to be this split over here, and our X and Y, if you remember, is already defined from the previous video. So our X is defined over here. If you remember, this is our X and this is our Y. So it's all the raw data excluding transported passenger ID and name. And then our Y is the transported yes or no. So if we scroll down here again, so we have our X, we have our Y. This is for the cross validation. Verbose equals 3, number of jobs equals 4, and a random state of 34. If you want to read more about how this algorithm works, then you should read this documentation over here. Then we are feeding our X and our Y. We are getting the best parameters by running this. Actually, let me click run because it's going to take some time. I think it takes about 5 minutes. So I'm going to pause and then restart. So the CLF.best estimators is going to give us the model with the best estimators feed it in the model. So what I did over here is that I have stored the model I want to run into this final model, and then I'm calling this final model.feed on X and Y because before we fed it on all these parameters, but now I'm feeding it only with the best estimators, so the best parameters. Then I am scoring my model and I am also printing the logarithmic loss. This is not logistic, this is actually log loss. I made this mistake before. Now we're going to need to wait until the model finishes so we can evaluate our results. Right, so the model has finished. As you see, it took 6.1 minutes to finish. It gave us a score of 84%, so that's an improvement from 80%. And then the logistic, sorry, this is actually the log loss, not the logistic. I need to fix it. Why is this saying logistic? Anyway, it has fallen from 0.40 to 0.32. So this is actually an improvement. So now I can use this new model. By the way, before we use it, let me show you the best parameters. So CLF.best estimator, if I run it, you can see it gives us the model, so all the model with the best parameters already in. So instead of copying this and running it, I've just passed all this model as is back to the final model and then use final model.feed to feed my data with the best parameters. Right. So if I remove this quickly, the next step now is to make predictions on our X test, which is the unseen data, the data we haven't used to train the model. So it's literally a copy paste of this bit above here. So I copy this, I paste it down here, and then I change my Y predict to be coming from this final model. So this final model. So if I run this quickly, we are exporting submission 2. So if we try and submit it just to check our predictions on this one, so submit, then we select the second one we've just exported, so open. Then click submit submissions, and now we got a score of 0.7933. So 0.7933, so let's do 33, which is actually, let me check again, 0.331, yep, 331. So this is actually an improvement, I think. So if we check the previous one, it was 0.78, but now it's 0.79. So we've actually managed to improve our model. Let me check the first place. So the first place is 0.84. So we are about 5% out from the first place. Right, the next step now is to go back where we've replaced the missing values, and we are going to try a new method of replacing missing values. Because as you remember, we had a lot of missing values in the previous video when we did the analytics. And we've used the mode and the median in order to replace those missing values. However, now we are going to try a new method, a bit more sophisticated when it comes to replacing or filling in the missing values. So the first step here is to apply the same steps as before, so the cleaning steps up until the replacing missing values and get dummies. So we're going to leave this behind. So what I do is that I load the two files, train and test. I actually concatenate these two files, so I am unioning them into one single file. So if I run this quickly, so I'll show you the shapes. So the first file has 8,600 rows, the second file has 4,277 rows, but the third file, because I'm combining them together, it has the sum of these two. So it actually has all the raw data. However, I am actually dropping the Y variable, the transported column, because I'm not going to need this column for this step. Then after I combine the two datasets, I apply the same steps as before. So first I change the types. So we've explained this in the previous video. I'm adding the 3 new columns and I'm dropping cabin. Then I'm creating this cabin category new column. And then I am scaling the data for my numeric variables. And if I check the data now, we can see it's exactly the same data as we've cleaned it above. But the difference now is that we have both train and test combined, not just one file. So the method we are going to try and follow now is that as we have lots of missing values per column, we will try a new strategy. We will combine both data sets. So we have actually done this, and we are going to run XGBoost per column, so a classifier per column, and make predictions for those missing values. So instead of using mode and median to replace those missing values, I'm going to run multiple models and predict those missing values in order to fill the data in. To do this now, this is actually a bit complex, but hopefully you're going to understand the steps. The first step is that I am defining the two lists that I'm going to loop through. The first list is going to be my strings, which I'm going to use a classifier because I'm predicting a class. And the second list is going to be my numeric variables because I'm not going to use a classifier, I'm going to use a regressor in order to predict those numbers. This is so we can ignore the warnings. Next, I am also changing this passenger ID from string to be integer. The reason I do this is so at the end, I'll be able to join my Y variable back to the original data set, because if I drop this passenger ID and then I shuffle the data, I won't be able to match the correct passenger with the passenger ID and the Y variable. So this is why I'm making passenger ID as integer and I'm going to include it in the data model. But this is just for joining purposes. Then I have this try, delete, and except. This is because I'm creating some data frames further down below and I can rerun this as many times as I want. And down here is where we start our for loop, and this is going to be our first classifier. So we are going to start with home planet. Let me just run it quickly so you see the print, home planet. So it's going to start with home planet, it's going to print it, it's going to create a copy of our raw data. So this combined raw data we have just created, we create a copy. We are updating all the numbers with the median. So right now, because I am running the C, which is the string, so home planet, I am going to replace all numeric variables with the median, because right now I'm going to predict the home planet. Then I am going to update all the categorical variables with unknown. So everywhere where I have a none, so fill a name, I want to put unknown. Then I am going to create a new list, but in this new list, so first I copy my existing list, which is this one. So as you can see, I save it over here. And then I create this new list that is excluding my C. So this C is going to be home planet. So this new list now is going to have everything but the home planet. So it's going to have all of this new list I have just created with this bit of code. The reason I did this is so that I can turn my categorical variables into numeric representation without really changing my C, which is basically the home planet. Because remember, I'm going to predict the home planet, so I don't want to change it into zeros and ones, so numeric representation. So what I do here is that I am turning all the data but my C into numeric representation. Then I create this data too, which is basically everything but where the C is unknown. And on the contrary, I'm creating this data unknown, which is basically everything that the C equals unknown. So the reason I created these two new data frames is so that I can use this one that doesn't have any unknowns or NAs to train the data, and then this one to actually make predictions on the unknowns, and then replace the nonce with these new predictions. So moving on, I need to separate my X and my Y, and I use my data to drop the C. So I'm actually dropping my C because C is actually going to be my Y. Axis equals 1 dot values. And if you notice again, I'm taking this from data 2, which is everything but the NAs. Then I am running my model. So this is a gradient boosting classifier we have used before. I am feeding my model and I'm also printing the score. Down here, I am saving this score into score, and I am also saving the log loss into this log loss over here. Down here, I'm creating a data frame that has the variable, the score, and the log loss. And this try and except is basically going to fail this the first time and then store score2 into scores df. And then every time we rerun, we are going to store every new line into this data frame. So we're going to be building until we loop through all the columns. Then down here, X for unknown, make a prediction. So X unknown is data unknown. So data unknown is this one over here. I am dropping the C because I don't really want to have the C when making predictions. I am actually going to predict those C, which is the home planet to start with. And then I am feeding this X unknown into my clf.predict. So this classifier .predict to predict the home planet. Then I'm creating this new column called prediction, and I am storing my prediction, which is this one over here. And then I am limiting the df. So data unknown, I am storing only these two new columns, and then I am renaming them into passenger ID and also prediction plus my C. Because remember, we're going to start with home planet, but every time we loop through, we're going to have new columns. Then I am creating this data frame here, which is going to be the combined data with predictions. And I am basically merging the actuals with the predictions. I don't really need this going forward, but I have just created it so we can cross-check the numbers. And down here is where we are left joining on the original file, so we have less missing values in the next loop. So the way it works, if I quickly show you the two files, so we are using raw data, we are using this one .head, and then we are also using the data unknown. So if we do the head of this one too, you see what's going on, .head. So here we have the cabin category, because cabin category is the last column. So we've actually looped through every single column of these ones, and the last one is this one. This is why it's actually stored in here in the data unknown. So what this is going to do is that it's going to merge these two based on passenger ID. So if we merge this one with this one, and then this prediction is going to be attached over here at the end as the prediction. and it's only going to join on these passenger IDs that had nulls, because if you remember, when we created this data unknown, it was just the data where everything is missing value. So it's this one over here. So first we join, then we are replacing the C. So we start with home planet, but in our case, it's actually the cabin because it's the last one. So where the cabin is NA from our original data frame, replace it with the new column we have just joined, which was going to be down here, which is going to be this column over here. So this second line is going to replace all the NAs with the prediction. The third line is actually doing the same, just in case there are strings. So first one is NA, this one is in case there are strings. And the last bit is that we are dropping the prediction from our original data frame. So that's why we don't see the data over here. So if we check for null values, remember we have just imported the data over here. We haven't replaced any of the null values. All we did, it was just make predictions on the null values on the strings alone. So if we check the null values of this one, so let's do is NA and then dot sum, you can see that for our string columns, so these ones, everything we have looked through, we don't have any missing values. Another thing we can check is the accuracy of all these models we have run. So we have actually saved the data in here, the scores underscore df. So if we run this quickly, you can see that for home planet, we got a 92% accuracy on our missing data predictions, then 95% on this cry or sleep, then 70% destination. They are all quite good, apart from this side over here, which is close to random, is 56%, but we are going to leave that for now. Next, we need to repeat the same process, but for numerics. So numerics is all these columns over here. So it's exactly the same process. We loop through all of our numeric list, which is actually defined up here. So this is it. Then if we read the code again, it's pretty much going to be the same as above. First, we create a copy, then we change the nulls to unknowns, then we create this list without our y, which is basically the n, which is going to be the numeric column. Let me just run this quickly. Then we are updating the numbers apart from the one we are trying to predict with the mean. Then we are turning categorical variables into numeric representation. Then we are storing all the data. Actually, this should not be here. So we are creating a data frame. So this is actually data for knowns, not unknowns. So I had the wrong title there. So this is the data for only knowns, so not unknowns. Then down here we create the same thing but for unknowns, so data unknown. We separate the data x and y. We run a gradient boosting regressor. So now we are predicting a value, not a class. We feed the data, we post our score, our mean square error, and our mean absolute error. Then we are saving the scores in a DF so we can evaluate them later. So it's exactly the same steps as before. We are making predictions, then we are limiting the data frame so we can join it. Here we are joining the data frame into this combined data with predictions, which we don't really need for later on. And down here is the same as above. We are updating all the missing values with our predictions. So if we check our scores DF now, so this scores DF is going to have all the scores for the initial models we've run before. So all of these ones are classifications and these ones are regressions. So as you can see, 20% are square, 19. This one is 38, 47, 35. So for these numeric values, we didn't do as good. And the reason is because we have a lot of zeros. So for now, I'm not going to do anything. I'm going to test the results based on this cleaning. And later on, we can come back to them and figure out different ways of improving these models. But for now, this is the process that I wanted to show you. So instead of updating the missing values with the median, the mode, or the mean, this is another way of doing it. Is actually making predictions for your missing values using all the data to train your model. So we have not only used the train data, we have used the train combined with the test. Right, the next thing we have to do now that we have cleaned the data is that we need to try and run one simple model on this clean data and see how that is going to perform. However, if you remember, this clean data that we have just created does not have a y because we have dropped this y at the top. Where is it? I think it was over here. Because we had to combine the train and the test together, we couldn't do it because of the y, so now we don't have a y. So in order to do this, we'll need to bring back the y. So this is why I load the two files again. I make the passenger ID into integer for this new raw data too. And then I am using an inner join in order to join the raw data we have just created above. So this raw data with the predictions with the new raw data too, which is this one. However, because it's only going to match on passenger ID using this inner join, so whatever matches from both tables is going to stay in. This means that any data that is not going to be matching from the first table is going to get dropped. So as you can see, raw data 2, so this one has 8,600. The second file, the test, has 4,000. The combined raw data that we have used above here, so this one with the prediction has 12,000, so the combination. But now our raw data 2, as you can see, which is, no, actually the model data, which is this join over here, only has the same number of rows as the first data frame. And this is because we've used an inner join. So everything from the test file have been dropped using this inner join, and now we have a y. Down here, I'm repeating a similar process, but now I am using a left join. So everything from raw data that matches with this raw data is going to stay in. Everything else is going to be excluded. And this is leaving me with the X test, which basically has the number of rows of the second file. So the test data, as you can see over here. So now I have my model data to run my model and score it. And then I have my X test, which is basically the testing that we are going to submit in the Kaggle competition to test our model. So if we check our model data now, you can see it's exactly the same as before, with the only difference being that now for missing values, we have predicted them and not replaced them with averages, means, and modes. Right, down here, I am running a simple model on this new model data. So this new model data above, I'm separating my X, my Y, running a simple model, so not optimized, then making some predictions. So as you can see, the score of this one is 81% accuracy with 0.4, so it's not that good. So we didn't manage to improve it versus our optimized model above. But if we run the optimization now, the optimized model using these new predictions, let's see what score we are going to get. There we go, the model is done. It took 6.7 minutes to finish, to loop through all these parameters. By the way, it's a copy paste from above. The only difference that I didn't notice is that I have tested different accuracies. So here I've tested the ROC curve, then the negative log loss, and here the accuracy. And the accuracy gave me a classification accuracy of 0.869. which is this one over here. However, if you run it with the ROC curve or the negative log loss, it's going to give you 0.883, which is actually much better than our model before. So if we use this to make predictions now, so this is submission 3. So I'm running this above final model on my test data as we've shown before. This is going to give you an accuracy of 0.801 in the Kaggle competition and a place of 3 to 9. So you see how we started with 1,000 plus in our placement, and we've managed to bring it down to the 300s. If we keep working on this, we can improve this even further. Right, the next thing I have here is that we are going to try our model, so the same model, however, we are going to use less variables. Let me run this quickly because this model takes ages to run, so I can explain you while it's running. So you remember in the previous video that we have run the feature importances, so it was somewhere above, let me see, not here, I think it was down here, there we go. So we've created this final FI, which is the feature importances data frame that we've saved the most important features. So what I'm going to do now is that I'm going to select the first, I don't know, I think 14 up until here features, and then run the model using only the most important features. So I'm not going to use all the data, I'm going to use less data, which is basically what this model is doing right now. So the way to do this is that I have stored these first 14 features over here actually. Then I've taken the values, so this is my X now, my Y stay the same. So what I did is that I have just limited my X, and I am rerunning exactly the same model as above here. And since I don't want to wait another 6 minutes for this to finish, I'm going to continue on because I think I have saved the results. So in order to test this on our test data, we need to do the same for test. So we limit our X test, and then we make predictions, we output the predictions, and then we submit this CSV4 into the Titanic competition, and this is going to give us an accuracy of 0.80 and a place of 400 plus. So by limiting the data, we did not actually manage to improve our model. So this was not a good change that we did, but you never know, right? The reason we do this is because most of the times we tend to overfeed our data. So by using less features, we avoid overfeeding. But in our case, it didn't really help. The next step we are going to try now is the recursive feature elimination process, which is very similar with the previous process, but instead of manually selecting those features, we are going to use this algorithm, so this library provided by sklearn. So the first thing we have to do is to define our X and our Y. Then we need to call our estimator. So this is the gradient boosting classifier we used before. We are going to use this selector, and then here we are going to pass our estimator the number of features we want to keep. So here we're saying we want to keep 10 features, and then we are going to feed our X and our Y into this selector. And then if we run selector.support underscore, it's going to print those 10 features. So I'm going to pause this video until I finish running the above and then continue. There we go, so this is done. So if I run the features, it actually printed the features itself. So the 10 most important features identified by this recursive feature elimination process is these features over here. So what I did is that I have stored these features into this recursive feature elimination top features list, and then I've passed it back into my X. So from model data, so this is the data with the predictions we created above, I'm only selecting this column name, so these features dot values, and then I am saving this as my X, my Y is the same, and then I'm running the same model again. So this is going to take again 6-7 minutes until it finishes running. However, I'm not going to wait because I have run it before. So the results you are going to get on your X test is going to be 0.79%. So if you submit it, this is the value you're going to get with these top features. And this is going to give you a place of 400 plus. So again, we didn't manage to improve our model by using the top, how many? 10 features identified by this method, 10 features. Maybe we can try 12, 15, I don't know, 20. We can use all of them, but what's the point? We have used all of them before. We are trying to use only the most important ones. Actually, this method is going to be very helpful when you have tons and tons of variables, and not just, I don't know, 20, 25 variables that we have. Right, the next step now is running our final model. So we have tried a few methods of improving our model. We actually managed to improve it and push it to 0.88%, I think it was. Let me go back and check. Is this one over here, 88%, which is very high. And then if you submit this on the Kaggle competition, it's going to give you more than 80%, which is really good for one day of work. If you keep working with these methods I have just shown you and trying different combinations, you are eventually going to manage to improve your model as you go forward. Right, so what I have down here at the end, let me go running our final model, is that I've basically scrolled at the top. I have copied the model that performed the best, which is basically the model using the predicted values with the scoring method of either ROC, either negative log loss. This is going to give us, again, is running 88% accuracy. And then if you make the predictions into the X test and submit them into Kaggle, it's going to give you 0.80 and then 329 as your placement. The final thing I'm doing down here is that I am saving the combined results in a single CSV for my Power BI dashboard. So in order to create this dashboard, I have to combine my training with the predictions and my test with the predictions. So I have all the data so I can show it to the business. In order to do this, first I load my train and test. Then I add the new columns in the right order. So I'm adding the phase on both of them, the phase. I am adding the transported prediction on my X train, and then the probability yes or no for my X train. For the second file, which is the test data, I am adding the transported because it doesn't have transported. Then I am adding the prediction, which is the Y predict. I am adding the phase, which is the new data and seen data. And I'm also adding the probabilities for yes and no. Then I am concatenating these two files together. So these two files together with the predictions now. And then I'm applying some of the same steps as before. So I'm creating this tag, num and slide. I'm creating the cabin category. I am also changing the missive values to the mode and median. I could have used the predicted values, but it was going to take some more time to transform that. So I'm going to stick with this, which is easier. Then I am adding the model accuracy because we are displaying the accuracy above here. So 88%. And then I am exporting this into this CSV file where we are going to use in the next video in order to create this dashboard. Let me check, is this still running? Yeah, this is still running. So you need to be cautious when running all these loops because they do take their time. Right, so this is it for this video. I know it was not the easiest one to follow, but if I've spent all the time actually coding it and explaining everything, it was going to take us days in order to finish this, which is things you learn at uni. I suggest trying to write this as I go, trying to run bit by bit so you fully understand what's going on. So I hope you've enjoyed this video and you've gained enough value out of this video. If you feel like you did, then please click the like button, subscribe to my channel and enable notifications. If you have any suggestions, any notes or any ideas about my future videos, then please let me know in the comments below. Otherwise, thank you very much for watching this video and I'm going to see you in the next video.